Okay, my friends, it's Roger once again. I'm going to get ready to collect my $1 million prize to fund my new school. And a $1 million math prize awaits anyone who can solve the type of equation used in QCD to show how massive entities like protons form. Well, what is a proton made of? Right now, they know absolutely nothing, to be honest with you. They know that they call them quarks and gluons and bosons and fermions and muons and electron showers and all kinds of things that they see coming apart when they smash the particles, but they really don't know how they started, how they originated, and how to put it back together. I'm going to show you how they are constructed, what they are made of, how many they are of these particles, and what they look like. I'll show you the actual particles and how many there are in protons. And I will make it extremely obvious and simple because it's a new theory called electron flood theory. Now, the Bohr model was a gigantic nucleus of protons and neutrons. Okay, so they could have protons and neutrons, and then they had like little tiny bitty little particles way out here that were called electrons. Well, that doesn't work because you cannot have a big positive core and little tiny negatives. They just go together. I have always said that the core of every particle has to be a dipole. There is nothing but dipoles. And I've shown this over and over and over again for 50 years. Well, 6 or 7 years ago, Rod Warren did some experiments and actually accidentally showed that light can accelerate, light is a particle, light can be actually divided. And I worked with him for years on this, and the result is that we have found the particles that they're looking for, and these are tinier than protons because these are light particles. These are photons. Now let me show you the results of the experiments. All right, let me just make a couple of statements in the beginning. The core of every particle is a ton of little particles called electrons. They're positive and negative together. And they make a ball instead of just one big gigantic proton. Because they know these are not just one big proton. There's all kind of particles in there, leptons and quarks and things. Now they're just gasping at anything to try to figure it out. Well, they're never going to figure out what the Bohr theory, because the Bohr theory is wrong. There is no solid, huge proton, and they know that, but now they're, like I say, they don't know what to do. Well, I do. It's all electrons, and electrons are positives and negatives, and there they are right there. And there's two of them make a light particle, and that's where the particle sits in the front of the wave going this way, and it has a magnetic field surrounding it, a big one. So when it goes through the air, everybody in front of it, they also have magnetic particles as part of them, because there is nothing that doesn't have electrons. So these electrons coming forward, which is the white balls, push the other white balls that are attached to all the other particles in space, the gases and so forth, and they concuss and they glow. Now, through a venturi, we can accelerate, and that particle that I just showed you, the black and white particle here, and there's two of them, there's two electrons back to back. That's why they bounce off of you. If there was just one of them, half of that, it would be an electricity. It would be just a bare electron. Two of them together is a photon. I'm going to show you my math and get ready to get my check for me, please. $1 million, and I can use it. Now, so here comes the particle. Zoom through the air. And what does it do when it hits the venturi? It literally explodes. Here we can see that it's being pulled out of its wave, just like a jet fighter, and bam, it explodes there, and the black explodes from the white, which is fission. That's all it is fission. All right, and this is exactly what it looks like up close and personal. The black and white separate, and the blacks go around, and they reattach over here. Now, I don't think they all just jump around. I think this black one's just waiting around, because they say there's a lot more dark energy than there is concussive energy that we can see. This energy that we can see, the only energy that we can see, radiates. If it doesn't radiate, you can't see it. Black stuff never radiates. It doesn't radiate. What we're looking at there is only there because of what's behind it and how we separated it. It doesn't emit, it doesn't absorb, it doesn't concuss, it doesn't reflect. It's dark matter, it's muons, they call them bosons, carriers. This is the white matter, which is electron showers, fermions. They have a million names for everything now. So I'm saying the black balls and the white balls are nothing more than the electron shower particles that are the energetic particles, and the black ones are nothing more than gravity and no dark matter, and they can attach back to here. Now I say that we could use this right here to harvest energy, and all we'd have to do is put a solar collector plate in there, and all it would be just something like the laser comes through here for 5 watts. It ends up being 200 times more powerful right there, and then you just harvest it down through a solar plate, collect it, and that's it. We're not talking about any big problem, because it's just nothing more than a solar panel here. And everybody knows how, well, not everybody, but people that know how to deal with solar collection know that they're going to collect electrons. And they have to push those electrons down into some kind of an absorption device. And that's all done. That's all, that stuff is ready to go. All we need to do is get a good laser, tune it up so that it gives us the most power over here, and create some thin film solar collector panels, which are very cheap, very, very cheap compared to solar panels you have to put outside and weather them in a storm. And you could carry these things around in your hand and power a house, car, everything, and it was just run by itself. If you can increase the power by 200 times, it's free energy. Solid state, not a single moving part. All right, so don't forget, I showed you the particles separating, and that's exactly what they want to see. A muon neutrino, the black ball, attached to a white ball, the electron neutrino. When they concuss, the muon goes on its way, the black ball, and the white ball turns into the showers. And there it is right there. There's no mystery here whatsoever. And this is fission, because it is separated. This is fusion. It came back together. There's nobody can dispute that. And that's exactly what they say they want to see here for these muon neutrinos and the muons and electron showers. You just saw them. All right, so let's get back to what is our photon, our proton constructed of. Well, it's constructed of 1839, I believe. They could say 1836, 1837. Well, the number they have right now is not correct. I can guarantee you that, because it's either 1839 and 1840, which is 1839 would be the proton, 1840 would be the neutron, because 1839 makes it not an even number. If it's an even number like 2, it's sort of neutral. That will bounce off you. Okay? If there's only one there, it wants another one. That makes it the same thing as a charged particle. An electron is nothing more than a charged particle. And it wants another one to snap onto it, and then it becomes light. It would really like to be involved with a whole batch of other particles to create matter. But when, you know, there's a lot to this. There's a lot more. I'm trying to make it sound simple. It's not simple, but it's not real hard either. If you take the dark matter, nobody's ever seen this before, and you will not see this concuss like this. If I show you particles of coming through the air, you can see there's nothing whatsoever happen except for right where they're smashing into the venturi, because the particles are concussing on themselves. They're pulsed, which means they pulse and push back, pulse and push back. It's like AC power, very, very devastating amount of power compared to DC. Anyway, the particles we're seeing right there, 1839 create a proton. 1840, I say, is a neutron. Now, it could be a little less than that. Let me show you the calculations they did. But I can also show you that they're not correct, because it's got to be an even number. It's not going to be 1839.275, and that's the kind of stuff they're coming up with. All right, see this? $1 million math prize awaits anyone who can solve the type of equation used to show these massive entities like protons form. Well, I think I could show it, and I think I will, and I can show the math behind it. And they say what goes on in a proton, quark math, still conflicts with experiments. So yeah, experiments I just showed you. And they're seeing these things, they don't know what to say. Nobody's contacting me back, but I've contacted all of them, so I know they're seeing it. And this is the new electron, well, somebody did contact me back, Fermilab, and we had a big fight, a very big fight, Don Lincoln and I think he's been, he will not look, he says, I won't spend 1 minute looking at your stuff. That's not right. He's a government employee. I'm showing stuff that's pretty valid. So anyway, that's a whole other issue. Now, I say electron flood theory is the new Bohr model because Bohr didn't work. Everything's made of electrons, and they are made of muons and electrons, what we would always call a muon electron neutrino. The photons are back-to-back electrons. That's what comes out of light. Protons are 1,839 of those electrons, and they're in a ball just like that. All right? They would be very similar to this. And all of the white particles would be around the black particle that's in the center. That's why we never see it, because it doesn't do anything. It doesn't radiate. It's gravity. So all the white ones are going to want to stay away from each other. They'll create a complete incrustation around the black core. So it won't really look like that, but I just did that so you could see in the center is going to be the blackness. And that's what every atom and every proton and everything that is a molecule is made of. That dark matter is going to go towards the center of each piece of the atom. And so that'll be where it's collecting. And it collects in certain numbers called resonance frequencies. And they are going to be combined of these kind of quantities, somewhere around 1839 for a proton, 1840 for a neutron. Because the neutron doesn't want to attract or give up an electron. The proton wants to attract another electron. That's why it's basically a charged particle. That's why they've always decided, well, it has to be a charged particle, so it keeps the electron floating around it. Well, no, it would just go just like that. I mean, it's just not, it never made sense, and I went insane about this 50 years ago. I have my paper somewhere around here that shows that I said there's nothing but dipoles. It can't be. It's impossible. Anyway, that brings up a real sore spot, because I had decided I would go into this, and I did go into it deeply, and I was just destroyed for raising my voice. That shall not happen anymore. Now, what do we have here? Let's talk about the math, because that's what they want to give $1 million for. Somebody can say how this is constructed. How are these protons constructed? All right, listen to this. What goes on in a proton? Quark math still conflicts with the experiments. Just as I said, yes. Two ways of approximating the ultra-complicated math that governs quark particles have recently come into conflict. Well, they're so ultra-complicated, nobody understands them in the first place. Secondly, they can't work because they're not right, leaving physicists unsure what their decades-old theory predicts. It predicts nothing. It's just nonsense. Here's what the real story is with atomic matter. Electron flood model. It's nothing more than these electrons. I showed you those back to back. They're electrons. And we call them electron neutrinos, muon neutrinos. And they are the most tiny stable particle, an electron. The most tiny, basically stable particle. And I know they're stable because you can walk around in the air and collect electrons on you, excess electrons on you, and then discharge them to ground, and you see a little spark go. And all they are is electrons. They're not light. All right? And electrons also are the source of excess heat. All heat is electrons. And things weigh more when they're hot. You probably didn't know that, but look it up. Anything that gets hotter and it is exactly the same to start with, it will weigh more. Gases are different because they expand, so they're going to go up. Totally different situation. But if you started with this thing, two of these exactly identical, and heated one up, it would weigh more than the other one. Now, all matter from electrons. So all matter is from electrons. There's nothing that doesn't exist of electrons. They're all made like this. And they're in stable quantities called atoms and elements and molecules and so forth. Now, here's the math. And this is the ultra-complicated math. A proton is considered one atomic mass unit. So that's one. All right, that's the proton. If you divide the weight of an electron, and they say the weight of an electron is approximately 0.005438 atomic mass units. You divide that into a proton, weight, which is 1, you end up with 1,839 approximately electrons. I say approximately because it could be 1836. They come up with that number 1836 in 2014, but they came up with 1820, 1836 point, and you can't have a point. It's going to be a whole number. An electron is an electron. Every electron is the same in my world. And I can show you the green ones, the red ones, identical. The blue ones are hard to see. They're just too energetic. Anyway, photons are 2 of those electrons. I showed you that. And they say there's an upspin and a downspin. And yes, there is. That's because of the polarity of the Earth. This one here, the concussive part is down. That one there, the concussive part is up. And in front of them, you'll see little glowy particles will glow because that's the one that's concussing. So going through the air, and they are spinning at the same time because of that concussion. It forces them to spin. They charge up, and then they flip. They charge up, and then they flip. That one charges up, it flips. Now that one's in the front. It charges up, and then it flips. Now, all matter greater than light creates a ball, which I showed you, which is a ball of particles just like this. The black part will be in the center, and completely encrusting it is white. So whenever you look at it, the only thing that's going to reflect back at you is what the surface is. And the surface will always be electrons. And there'll be certain electrons in certain levels depending upon what the matter it is. So you might get a blue, you might get a green, you might get all kinds of different colors coming back. But all that is reflectivity. All right, so they have to be the bouncers, and the only bouncers are the white ones. Now, so the white surrounds the black. It completely surrounds it. The black is, in the center, is muons, gravity, bosons, and it's dark matter. Nobody's ever seen it before. So that's my model of ultra-extensive math. Okay, once again, so they have no clue about the proton. They're just lost, basically, is what it boils down to. If electron flood theory is right, they are so lost they're never going to get there unless they just stop and start to think. Objects are made of atoms. Atoms likewise sum of their parts, electrons, protons, and neutrons. No, they're all made of electrons. And electrons are made of a dark part and an explosive part. That's it. Protons are 1839, neutrons are 1840 of the electrons. Now, dive in one of those protons or neutrons, however, and things get weird. Yeah, because they can't account for it, what they're looking for. 3 particles called quarks ricochet back and forth. No, 1,839 particles called electrons glue together. They bounce back and forth nearly the speed of light, snapped back by interconnected strings of particles called gluons. Well, bizarrely, the proton's mass must somehow arise from the energy of the stretchy gluon strings, since quarks weigh very little and gluons nothing at all. That's just not correct. And this is not, I don't think, very long ago, I don't think. I don't know, this part, I think this just came out. But anyway, this goes back to my stuff, goes back a bazillion years ago. When I first got out of the Army, I was in nuclear missiles, Navy Hercules missiles during Vietnam era, 1970. I got out, and I went into, deep as you could get into atomic stuff. And this is all light waves. This is the polychromatic, different frequencies and wavelengths and so forth, and trying to figure out what they represent. Back then, we didn't have a lot of the tools you have now. So, and I said particle nature, the momentum and energy stream of high velocity energy packets called photons. They're high energy packets. Now, all I could say was they're high energy packets, but they're photons. They're particle. They're particle. I knew that way back then. I knew this is spin. I spun, and I know all the things that they gave me trouble with and fought about everything I presented, every single thing I presented about dipoles and the nature of everything. It was a dipole. And finally, I said, to hell with you people, and you got out of it. So all you can do is follow the leader if you want to stay employed in that business or you want to get anywhere in there. Otherwise, they literally fail you. I'm serious. If you won't play that game, you will not be in that club. And if you're not in that club, you get nowhere. If that's your desire in life to get along with those people, it's just not going to happen. Unless you just say, oh yeah, oh boy, you guys are so smart. Well, as soon as you bring up something and then you back it up with something, forget about it. It's all over. You're attacked like you can't believe. Okay, this is Max Planck Institute, and they're talking about electron on the scale and the measurement of electrons. This goes back to February 2014. Now, it says this is one of the most important things in the fundamentals of the laws of physics. How much does an electron weigh? Well, they had no clue, and they used to consider it have almost no weight at all. So it says electrons are the quantum glue of our world. Basically, that's true. They're the explosive part, but they're also glue, correct. Without electrons, there'd be no chemistry, and light would be unable to interact with matter. I agree with that. If electrons were only a little heavier or lighter than they are, the world would look radically different. Probably, I agree with that. How can a particle which is so tiny that it hasn't so far been considered point-like, which means there's no mass there at all, actually be weighed? How can it weigh something like that? This feat has now been achieved in a collaborative project involving physicists from Max Planck Institute for Nuclear Physics in Heidelberg, who weighed the mass of the electron 13 times more precisely than previously known. Well, we'll see about that. As electrons' mass is involved in fundamental physical constants, it is of significance to fundamental physics. Absolutely. Now, let's look into this a little deeper. And don't forget, this is my contention. These are electrons, but they also have a dark side, never seen before, because they just don't exhibit themselves until you do what we did with the Venturi. This is what the photon looks like. It's two of those back to back. Showed it, hopefully you understand. Protons are 1,839 of them, which is an encrusted ball of dark matter with the white matter. The white matter radiates, we can see. The dark matter strictly absorbs. Strictly is gravity. It doesn't absorb any energy, none at all. It doesn't emit any energy, none at all. It doesn't reflect any energy, none at all. It doesn't reflect anything at all. It doesn't concuss. It will not go through that Venturi if we tune it correctly. And at that point, it will separate from the white matter, whether or not, I can't actually account for that, whether the white matter is crushable and the black matter is not, and therefore it has a heavier, it's heavier, but when there's an impact, the white matter becomes heavier. I have no idea. But I can tell you one thing, it will not go through that Venturi if it's tuned correctly, and the white matter goes through as the showers, precisely as I showed you. So this brings us to Max Planck talking about electrons, quantum glue, and all this stuff of our world. How are we going to understand this stuff? Well, somewhere down here. They say they've done all this, and the only way they can do this is only a theoretical contribution enabled this measurement. A theoretical, everything for them is theoretical. So they came out with this result. The result is a fantastically precise number, revealing that an electron has a mass 1,836, I say 1839, 0.15267377, that of a photon. Of a proton. Well, let me tell you something. There is no such thing as a half of an electron or a 15 billionth of an electron or whatever you're talking about. Your electron is an electron. So, well, in my world, if electrons make up protons, then there's 1,800. Let's say it's 1836. I don't care. 1838, 1839, but it's not going to be an even number either. It's not going to be an 836 or a 38 or a 40. It's going to be a 37 or a 39 or a 41, because a proton is a charged particle, basically. All right? Although the electron truly is a lightweight, it plays a heavyweight role in nature. Every single thing there is, 100% of everything, is made of electrons. And electrons become stable at certain quantities. All right, I showed you the particles separating. When they first start to concuss, you really don't see anything at all. Up in this area, you don't see anything because there's no concussion. Here, there's concussion because it's directly in line with the Venturi. So they start to display here. Otherwise, you wouldn't see anything at all. You would just see a little bit of glowiness like up in here, this area now. So now we're seeing them Well, this is called neutrino oscillations. They come in flat and then they twist sideways like this. This one's already concussing because, again, it's right in the line of fire here. These up here are going sideways, but originally they would have started like this. Now, the box forms and then the explosion happens and they separate from each other. Now, the green is identical. So the particle is not, there's no difference in the particle, it's the speed of the spin. You know how I showed you the red ones, just nice particles, just like that, one right after the other? This is the only time I've seen this, is that particle looks like to me that it's right in the midst of flopping. And you see how brilliant that particle is? This is the same particle, but it's being charged. So this is beginning to glow here, and then it's going to flop, and then the white ball back here will come to the front. So, but this, you know, but it has to charge up. So it takes a certain amount of time to do that. And it's like our sun. Our sun flips its poles, and that's all it is a polar flip. So the white is going to be on the bottom instead of at the top, leading. You see. Now the sun does the same thing. It leads for a certain while, and then it builds up, and when it only takes 27 days to flip the poles and go into I think they call it the solar minimum. But between those two times, which is 11 years, it stays on that solar minimum, and then 27 days, bloop, it flops. And I think this is the same sort of thing. It literally charges up the white coming forward until it starts to glow, and it pushes it away to make it spin. That's the only thing I can come up with, because you don't see that very often. Well, that's the only time I've seen it. Now this is what you normally see. It's like this. It's white on like that instead of real glowy white. That looked to me like it was just getting ready to flop. But the harder they concuss, the more you get a glow like this, and then all of a sudden it'll pop. That's my opinion at this moment, because they spin. There's no question they spin. And this is, I believe, MIT. They understand it spins. They talk about it as being chirility. And as the particle comes through the air, it's called the right-hand rule. If it's spinning in this direction, it's going that direction. The light is going this direction if it's spinning that way. The right-hand rule. Now, they're showing, I don't really know what they're showing here, to be honest with you, but you know what my particles look like, a black and white ball. And they impact all the other particles that are in the space in front of them. So they do basically do that. They sort of spin as they spin and hit them, charge up and then flip, and charge up and flip. That's what I think this is, which creates the spin. You know, this obviously somebody's got to look at it a lot closer, but that's been a little bit of a concern for me to try to understand that. But if they're going forward, and when they go forward, they're not going like crazy forward. They're going like our planet is going forward. They're going to be spinning this way. But somehow it makes them spin in a circle going forward. And that's exactly what's happening in the solar system. Our planet is going around in a circle like this, but we're also going forward and spinning in a big circle going around the sun. Let me show you that. And this is basically the same sort of a thing. The particle is spinning by itself as it's going around these circles, but it's going around a big circle. And that's exactly what we're doing around the sun. All right, this is the reality of what's going on. We are on the arm of the Milky Way, being dragged through the Milky Way, our sun. We are trailing our sun, spinning around the sun every year. It makes a yearly pass around the sun. And at the same time, we're spinning on our axis. So there's a lot of interplay here. And there's a lot of push to shove. And we're starting to try to get some new information on these polar fields. And I just got this stuff in, so I probably shouldn't even show it to you, but I will, just to tweak your interest, because there appears to be some new software that can actually see the intensities as fields. That's all I can take away from this, because I don't really do this stuff. This is Dylan Carpenter sent me these pictures. Hold on a second. Like I said, I just have no clue about this at the moment, but all I can take away from this is that this is the moon, apparently the way Dylan explained it to me, and he really just gave me like a half a dozen words. Yeah, I just took like a picture at night or something. And I can see all these polar fields interacting with each other, but this thing here is just absolutely stunning. The intense polar interaction. And the only thing I can think of is that it must be Venus, because Venus spins backwards in its daily spin. So we're spinning, you know, according to the easiest way of going through our solar system. Well, Venus was born just not that long ago, and it is spinning backwards. And because of that, its scrub going through the particles in space makes it 800 degrees or more on the surface. It's an extremely hot planet, and that's because it's scrubbing. It's like driving down the street with your tires going backwards, but being forced to go down the street, but you're driving your tires backwards. That's the kind of heat it's creating. And all energy is heat, and anytime you have a lot of glow, you have a lot of heat, and that's all I can assume. That must be what that has to be. But this really needs. Look at the other stuff. Where do you see some of this other stuff? Man, it's just stunning. Look at that. Look at this. These all must be stars, and they're all dipoles. Everything is a dipole. You see the black and white, black and white, black and white everywhere. You see it? Now this blows my mind. It looks like a pyramid out in space. I don't know. And this, I can't account for any of this stuff. But I can see a lot of interactions, energies, and what is this doing on top of the moon? If that's what it is. I don't know. Again, I have no idea. Or as we say in France, je ne sais pas. Okay, I'm going to leave it at this. This is light spinning at us, coming at us. That's the Higgs bosons. That's a light moving forward, just a regular field. That's the accelerated light. These are the particles, Higgs fields. That's the blue, a little too intense to see the actual particles. That's a real strange event down there. But everything has changed. It 100% changes because of electron flood theory. So, and what you have seen means it's not a theory, it's a fact. I just showed you these things. That's a fact. There's no question it's real. An electron has a muon attached to dark matter. Nobody's ever seen that before. And it instantaneously attaches back to the white. So the current unknown mysteries are gravity. I don't even know how things hit the floor. Light, is it a particle, is it a wave? Don Lincoln at Fermilab thinks it's a wave. There's no particle there. Well, obviously there's a particle, I've shown it. And he won't look at my stuff. That really annoys me, I gotta be honest with you. Space is not a vacuum. And again, I believe that's exactly what Don Lincoln, he just laughed at me. He says, you got to be crazy to think that we're scrubbing through space. I said, what do you think we're scrubbing through? Where do you think the light particles go? And then he blocked me after that. Anyway, they don't understand what heat is. They say, oh, it's just kinetic vibrations. No, it's not. It's electrons, free electrons, just like that, entering in as heat, being forced into that matrix of other particles of electrons, which are, there's little extra holes you can push things in here and there, and then they will flow back out to wherever there's extra holes waiting for them. That's just the nature of the heat. And cold falls to the ground. Cold is heavier. You know, I just realized cold is heavier in gases. If you open your freezer door, you'll see the cold air just falling out of there. It's exactly the opposite for heat. If you heat up gases, they go up. If you cool them, they go down. Well, with a solid object, if you heat it up, it's heavier. It's exactly the opposite. If you cool it down, it's lighter. All right? Gases, if you heat them up, they go up. So it's exactly opposite for gases versus solid objects. So when I said it, I'm thinking to myself, holy smokes, I just did something about heat adds weight. And I know this for a fact because I went to the weights and measures with weights to have them validated, and I had to leave them overnight because they were cold. And the guy says they won't weigh correctly if they're cold. And he didn't know why, but I know why now. There was not enough electrons in them. They had to absorb electrons from the room. That would have brought the weight right up. You know, not much, but enough. This was very, very sophisticated. They weights and measures for legal trade, and they have to be very, very precise, and they have to be sealed, and then we have to put a lead seal on them and all that, and you know, validate that they're legal for trade. So anyway, there's a lot. Anyway, I think I made my point, and I think I've shown that electrons create protons and photons and all the atoms and all the molecules there is. And because these little electron bits can attach so elegantly, we can have, you know, instead of having, you know, a carbon atom with a half a dozen particles, you've got a carbon atom with, you know, 12,000 particles. You can do a lot with that versus, you know, half a dozen, 12, whatever it is. So there's a lot to think about now. All right, don't forget, this is my goal, is to use this enormous increase in energy, 200 times they say, to put a solar panel here, something very similar to this. The laser increases from 5 watts to 1,000 watts and hits a solar collector, which is with transition metal, thin film transition metal, and then just goes straight down to a harvest device. That's all. As simple as a regular solar collector. No big deal whatsoever. 100% solid state. End of story. If we could do that, boy, I'll tell you, I'd be a happy camper, and I think the world could change overnight. And we could do this literally overnight. All the technology is here. There's nothing to invent. The storage devices, everybody knows how to use solar panels to feed energy and to store it. I mean, it's been all over the world. The lasers, obviously, you can see we got it right here. It's all done. All we need is the collection device here, and they are doing something with, now there's a new technology called percostrites or something, percostrites or something like that, and they're using transition metals, but they still don't realize you need all the transition metals because they collect all the different frequencies, and all you need is a thin film, and then you have to direct it down because we're just going to be collecting electrons. It should be looked at. And I sure wish Fermilab would turn around on this. It's very distressing to think that we're paying them billions of dollars. And he said, I won't use 1 minute. I won't take 1 minute to look at your stuff. You're not peer reviewed. I said, oh, you got to be kidding me. And no, he wasn't.